Now we're going to look at associations in categorical data. So let's look at cake or pie. The table displays the dessert preference and dominant hand, so left or right-handed, for a sample of 300 people. So for each of the calculations below, we're going to describe the interpretation of the percentage in terms of the situation. So for number 1, we have 10%, which comes from 10 divided by 100 is approximately or is equal to 0.1. So where does the 10 come from? Okay, where does the 100 come from? The total that prefers cake. So we're going to say out of the 100 people who prefer cake, 10% of them are left-handed. Okay. So for 67%, from 180 divided by 270 is approximately 67%. Where did the 180 come from? The right-handed. And that prefer pie. Where did the 270 come from?
The total people that are right-handed.
Okay, the total people that are right-handed. So we will say out of the 270 people, so out of the 270 people who are right-handed, 67% of them prefer pie. All right, so we have 30% from 90 divided by 300 equals 0.3. What does the 90 come from? The right-handed cake. And what did the 300 come from? The total number of people who were surveyed. So we're going to start this one out a little bit different. We're going to say 30%. Why did I not write that as a percentage in numbers? Does anybody know why? Because whenever you start a sentence, you have to write it out. Have you guys ever learned that in English yet?
No.
If you start a sentence with a number, you spell it out. So 30% of everyone surveyed is both right-handed and prefers cake. All right, so let's go down to 3.2, associations in categorical data. The two-way table displays data about 55 different locations. Scientists have a list of possible chemicals that may influence the health of the coral. They first look at how nitrate concentration might be related to coral health. The table displays the health of coral, healthy or unhealthy, and nitrate concentration, low or high. So we have all of this data here. and we're going to complete the two-way relative frequency table for the data in the two-way table in which the relative frequencies are based on the total for each column. So we're going to look, first we're going to look here. So our second column, for our healthy and low concentration, how am I going to make that a percentage? This is similar to what we did yesterday. Remember when we were looking at the columns? What did we divide everything by?
28.
The what?
55.
We're looking at the column, though. So 28. So we're going to divide the number of healthy coral by the total in the low concentration. Oh, not 25, 28. Sorry, I'm just going to rewrite that. 20 divided by 28 is 71%. So what are we going to do for the unhealthy and the low concentration?
By 28.
29.
So 8 divided by 28, and that is approximately 29%. Does 71% plus 29% equal 100%?
Yes.
Yes, it should. Okay, for our high nitrate concentration, let's do blue for this column. What am I going to do for the high nitrate concentration and healthy coral? We're going to divide by 27, so what are we going to start with? 5 divided by 27, that is approximately 19%. Okay, what are we going to do for the high nitrate concentration and unhealthy coral? Okay, 22 divided by 27. And that is going to be approximately 81%. Does 19% plus 81% equal 100%? Yes. All right. So, when there is low nitrate concentration, which had a higher relative frequency, the healthy or unhealthy coral? The healthy. How'd you get that? Okay, because it is 71%. Okay, let's go to the next page. We are going to have to kind of flip back and forth, so I'm going to take a picture of this right here and put it on the next page so that we don't have to flip back and forth and you can just pay attention to what's on the board. So let's add that here. Oops, let's undo that. All right. So, when there is a high concentration, a high nitrate concentration, is there a higher relative frequency of healthy or unhealthy coral? Unhealthy. How do we get the unhealthy? Because there's 81% of unhealthy coral in a high nitrate concentration. Based on this data, is there a possible association? You may have to look at your page if you can't read what's on the board because it is kind of small. So is there a possible association between coral health and the level of nitrate concentration? Yes. Why do you think yes?
Because when there is high nitrate concentration, the corals are healthy.
Right. So yes. Let me come over here. Because when there is a high nitrate concentration. %, of coral was unhealthy. Whereas 71% of the coral was healthy when there was a lower concentration. So there was 71% of, sorry, maybe I need to, not there was. We'll just say 71. Of coral was healthy in a low nitrate concentration. Okay. The scientist next looked at how silicon dioxide concentration might be related to coral health. The relative frequencies based on the total for each column are shown in the table. Based on this data, is there a possible association between coral health and the level of silicon dioxide concentration? So looking at those percentages, does it seem that there is an association there? Why not? So our percentages of healthy coral are relatively close. Do you see that and agree with that? They're only 2% different. What about the unhealthy ones? Are those really close as well?
Yeah.
Okay, so it does not appear to have an association. Because the percentage of healthy coral was similar. All right, so now we have Jada. She surveyed 300 people from various age groups about their shoe preference. The two-way table summarizes the results of the survey. Jada concludes that there is a possible association between age and shoe preference. Is Jada's conclusion reasonable? And explain why. So in this case, if we look at the rows and we say, it may be best to put this into percentages so you can see that. So I'm going to grab my calculator really quick. If we take 21 and divide it by, not 57, we're looking at the rows. We're looking at the age association. So we're going to divide by 36 this time. This would be 58.3%. We'll just keep it at 58% though. And 12 divided by 36 is 33%. And 3 divided by 36 is 8%. Okay? Those might be slightly off because that's not going to add up to, let's see here, 58 plus 33 plus 8. That is 99%. So because each of those had a third on it, that doesn't work very well. So I'm going to add that third onto here. So that was 58.3% and 33.3% and 8.3%. So that gets it like right up to 100%. It'll be 99.9 and we'll round it up. Okay, let's use red for this one, the 11 to 17-year-olds. Let's look at the percentages. So we're going to take 21 and divide it by 108. And we get 19.4%. 48 divided by 108 is 44.4%. And then 39 divided by 108 is 36%, 36.1. All right, last one we're going to do is this one. So we have 15 divided by 156 is 9.6%. 54 divided by 156 is 34.6%. And 87 divided by 156 is 56%. 56.8%. We'll go with. Yeah. Okay. So, what do you notice about these percentages? Is the highest percentage for each age group in the same shoe column? No. What's the highest one for the 4 to 10-year-olds? Without laces. So sneakers without laces. Okay. What about the 11 to 17-year-olds? Okay, so sneakers with laces. And lastly, 18 to 24-year-olds. Not sneakers. So they were all a different shoe preference, right? So we can say yes, because 4 to 10 preferred sneakers without laces. And that's a W\O. I don't know if any of your other teachers have used that yet, but that's a fast way to write without if you haven't done shorthand before. The 11 to 17-year-olds preferred, I think that's supposed to have 2 R's. What? Never mind. Okay. Preferred sneakers with laces. And 18 to 24 preferred shoes that were not sneakers. All right, we have our last problem here. The two-way table summarizes data on writing utensil preference and dominant hand for a sample of 100 people. Is there a possible association between dominant hand and writing utensil preference? So if we look down the columns for this one, we look at our dominant hands, so left-handed and right-handed. About what percentage of left-handed people preferred pen? Anybody know? If there are 13 people, what is about half of that? 6.5. Between 6 and 7, right? So both of those are about halfway, right? So this one's going to be slightly over half. If I plug it in, it's technically 54%. And this one is 46%. So is there a possible association here? If you're left-handed, are you going to automatically prefer pen or pencil?
I mean, kind of, because when you're left-handed, your hand can smudge the pencil.
You can smudge the pen too. Like gel pens. Okay, what about right-handed? Does it look like that one's close to half?
No,
No. Why not?
because 8.5.
They're completely different. So this is going to be 94%. And this one will be 6%. So, is there a possible association between dominant hand and writing utensil preference? For left-handed, I don't think there is. What about for right-handed? Do you think there's an association there?
Yes.
I think so.
Is mechanical pencil considered a pen or a pencil?
It's still pencil. I think it has to do with
I
the...
don't agree with the right-handed then. I feel like most people just would want a mechanical pencil.
Depends on where you survey the people. So, left-handed is fairly evenly split. Right-handed seems to be overwhelmingly preferred. Here. Instead of seems to overwhelmingly prefer pen. Not B. That was not really good grammar. Okay, so there seems to be an association between with utensil preference and handedness, specifically for right-handed people. So, yes, specifically, there seems to be an association with right-handed preferring pen. All right, you guys do have practice problems on Canvas. Tomorrow you are going to have a sub and you will have a quiz on Canvas.
Why do you have so many subs?